Welcome back to the Solutions Manual. In this video, we will solve the problem 2.13 from Alexander and Sadiku Fundamentals of Electric Circuits 5th edition. According to this problem, for the circuit in figure 2.77, in this circuit, use KCL to find the branch currents I1 to I4. So we have to use the Kirchhoffs Current Law, also known as KCL in short. But before that, we have to consider a sign convention. So the current entering the node will be considered as positive and the current leaving the node will be considered as negative. So we have to consider this sign convention. So here I have four nodes, 1, 2, 3, and that's the fourth one. So for I2, we have to consider the node 2. So if I apply the KCL, which is algebraic sum of current entering the node and leaving the node is equals to 0. So I2, this 7 ampere and this 3 ampere current all are leaving the node. So they all will be considered as negative according to the sign convention. So we have negative I2, negative 7, negative 3 equals to 0. So from here I2 comes out to be negative 10 amperes. Now you might be wondering why we are getting this negative answer. The negative answer means that the direction we had assumed for the I2 current is incorrect. I2 is not away from the node, but it is towards the node. This is the actual direction of I2 current, towards the node. This is our first answer. Now for I4, I can consider the node 4. Again applying the KCL, summations of current entering and leaving the node equals to 0. So 2 amperes is entering the node 4. I4 and 4 amperes are leaving the node. So 2 ampere will be considered as positive. 4 amperes will be considered as negative. And I4 will also be considered as negative according to the sign convention, equals to 0. So upon simplification, I4 comes out to be negative 2 amperes. Again, we are getting the negative answer. So negative means that the direction we had assumed earlier for I4 is incorrect. In fact, I4 is towards the node 4. So this is our second answer. Now for the current I3, we can consider the node 3 and again applying the KCL, summations of current entering and leaving the node equals to 0. 7 ampere and I4 are entering the node, so they will be considered as positive. I3 is leaving the node, so it will be considered as negative. So 7 plus I4 minus I3 equals to 0. So I3 is equals to 7 plus I4 and I4 is negative 2. So upon simplification, I3 comes out to be 5 amperes. So this is our third answer. Now we have to find the last current, which is the current I1. So for I1, we can consider the node 1. And at node 1, I1 is entering the node and I2 is also entering the node. So these two will be considered as positive. 2 ampere is leaving the node, so it will be considered as negative. So we have I1 plus I2 minus 2 equals to 0. So upon simplification, we have I1 is equals to 2 minus I2, and I2 is negative 10. So I1 comes out to be 12 amperes. And this is our fourth answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the KCL or in the KVL, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.